Hello everyone. Today we are going to study about the another class of the refrigeration and air conditioning. This is class number 6. I am Aravind P. Today we are going to study about the applications of the refrigeration and the also the heat engine, refrigerator and heat pump. In the application of the refrigeration, there are mainly 5 numbers of the applications are provided. First one is the domestic refrigeration, second one is the commercial refrigeration, third one is the industrial refrigeration, fourth one is the transport refrigeration, fifth one is the air conditioning. So what is a domestic refrigeration? So domestic refrigeration deals with providing a low temperature place for preserving the eatables, drinks and medicines. So the use of the refrigerator in our kitchen for the storage of foods and fruits and vegetables has to allow to add a fresh salad in our diet for year around. So now there is a lot of fish and meats items we have to store, and we can store in the it in the domestic refrigeration. So it is some of the meats and fishes should need a longer time period for the storage. So we can also provide this domestic refrigeration for storing these types of the food items. The next one is the commercial refrigeration. In the commercial refrigeration, it is related to the refrigeration fixtures of the type of used by the restaurants and hotels. So not only there, some retail stores and institutions for the storing and displaying and also processing the dispensing of the perishable commodities of the different types actually. So next one is coming to the industrial refrigeration. Here we are concerning about the systems which are larger in size and cooling capacity that whose those the commercial applications like the industrial applications like ice and large food plants and chilling and storage of the foodstuffs including the beverage, meat and poultry products and dairy products, vegetables and also fruits and fruit juices, etc. The processing of the food products and the farm crops, which also we can store in some refrigeration systems which are provided in the industrial refrigeration, and the processing of also the textiles, printing work and photographic materials we can also store in the industrial refrigeration, which all are coming under the industrial refrigeration. And also some oil refineries and some synthetic rubber manufacturing field, the industrial refrigeration is applied. So in some oil refineries, the chemical manufacturing and petrochemical plants and the refrigeration is also used for maintain a process as they are required to the low temperatures. So it is also used for to liquefy the gases like oxygen, nitrogen, propane and methane. So some compressed air purification we need this industrial type of refrigeration. So it is used to condensate the water vapor from the compressed air in to reduce its moisture air content. Okay, the next one is for the transport refrigeration. Okay, for the transport refrigeration system, so we apply this to the refrigerator railway cars and also the trucks for local delivery and also the long distance transport for the some sensitive food like items like fish items and some other materials. Okay, so the next one is for the air conditioning actually. So what is mean by the air conditioning? So air conditioning, which refers to a simultaneous control of the temperature and humidity and also the cleanliness of the air motion. As you know that we are need some space which should be cooled to provide the comfortable and healthy conditions for the occupants is called comfort air conditioning. So the residences and the offices, theaters and hospitals which need these spaces for the air condition for these purposes. So there are some manufactured process which need to be done under the control of the environmental conditions. Even some of the sophisticated and precision of the instruments which need to control these conditions for the effective working of and keep up. So the conditioning done is for this purpose is called industrial air conditioning, and this is concerned with the production of the environmental which is suitable for this some computer centers and also some pharmaceutical units and also these printing works and photographic products. So the precision of these devices and the production shop laboratories, etc. So these applications are in the given above, which is clearly indicate that the refrigeration and air conditioning, which was considered the luxury and the society in a few decades, but nowadays it is very necessary for the present society and the tool for the higher productivity. So these are about these in the cases of this application of the refrigeration. But now we are going to study about this heat engine and also this heat pump and the refrigeration, the total refrigerant. So what is exactly the heat engine? So heat engine, which is a thermodynamic device which is used to continuous process production of the work from the heat when the operating in a cyclic process. As you know that both heat and work interactions takes place across the boundary of this cyclically operating device. So the essentially a heat engine which takes from the heat from the combustion of the fuel and convert the some part of this energy which into the mechanical work. So the heat engine which is characterized by the following features. So first one is the resumption of this heat Q1, which is having a high temperature source at T1, and the partial conversion of this heat received into the mechanical work, and the rejection of this remaining heat Q2 to a lower temperature sink at the temperature T2, and then the cyclic or the continuous operation. Then it is the working substances flowing through the engine. So the figure given below, which shows that there is a source and the sink which is having a temperature of T1 and T2, and the energy that is Q1 which is passing from the source, which is because of this heat engine is working. So we can see that there is when the energy of Q1 which is given from the or getting from the source, which is some part of this amount of this heat which is turned to as a work, and the balance will be going to the sink T2. Now this performance in the cases of the what is mean by the performance actually. So the performance of any machine which is expressed as the ratio of what we want or to what we have to pay for. So in the context of this an engine, the work is obtained as an expense of the heat input. Accordingly, the performance of a heat engine is given by a net work of output to the entire amount of heat which is supplied to the working medium, and the ratio is called the thermal efficiency. And the thermal efficiency is a measure of the degree of a useful utilization of the heat received in a heat engine. So it is given in the equation that eta of thermal which is equal to the net work output divided by the total heat supplied. And the you can see that in the figure, and you can there is two equations are which is given, that is W is equal to Q1 minus Q2, where Q1 is the heat amount which is getting from the source and Q2 is the heat amount which is going to the sink. So the equation becomes eta Th is equal to Q1 minus Q2 divided by Q1, which is equal to 1 minus Q2 divided by Q1. So obviously this thermal efficiency of this heat engine is operating between the two thermal reservoirs, which is always less than unity. To increase this thermal efficiency, it is necessary to reduce this Q2 with the Q1. So Q2 is the heat rejected and Q1 is the heat supplied. So it will remain the constant. So the thermal efficiency could be equal to unity, or Q1 which is going to infinity and Q2 is equal to 0, then it cannot be realized in practice. So next one we studied about these refrigerators and heat pumps. So the refrigerator and the heat pumps are the revised heat engines. The objective of this reversed means that it is backwards. So that means the direction of the heat and the work interactions are opposite to that of the heat engine. That is some work input and the heat output. So these machines, that is the refrigerators and heat pumps, which are used to remove the heat from a body at lower temperature level and then transfer into heat into another body at higher potential temperature, when the main purpose of this machine, which is remove the heat from the cooled space, is called a refrigerator. And a refrigerator which is operates between this temperature of these surroundings and the temperature below that of the surroundings. So refrigerators are very essential for our daily purposes, like for preserve food items and the drugs, and also the low temperature. So the term heat pump. Next, the heat pump which is applied to a machine which is objective is to heat a medium which may already be warmer than the surroundings. And yeah, a heat pump which operates between the temperature of the surroundings and the temperature above that of the surroundings. So the heat pumps are generally used to keep the rooms and warm in the winter. The source and the sink containing some infinite amount of energy which is always considered to be the temperature higher than that of the sink. So however, there will be some relative terms, that is atmosphere, which is we can use as a source or the sink. In the working of a refrigerator case, the surroundings becomes the source and compared to the space being cooled. But in the case of the heat pump, the surroundings become the sink and compared with the room which is to be heated. So the transfer of these against this reverse temperature gradient in a refrigerator and heat pump, which is accomplished by supplying the energy to the machine. So there will be some figures which shows that about this heat pump and refrigerator. You can see here that there is a space being heated is in the above. In the cases of heat pump, there will be a space is to be heated, and the bottom there will be some surroundings is provided. So the heat pump which is taking the heat from the surroundings and provided to the space to be heated actually. So the heat pump is used for a space which is to be heated actually. So the temperature of there should be is greater than the temperature of the atmosphere. So what the heat pump is doing is it getting some work input from the some energy which we are going to provide. From that, this using this work input and some amount of energy is from taking from the surroundings and provided to the space being heated. So it is given that there is a Q2 is the amount of heat is getting from the surroundings, and Q1 is the heat which is the overall heat, that is a Q2 plus W. So that is provided to the Q1, and which is to be the space being heated. So the next figure, in this figure, the refrigerator, there will be that machine which is taking a heat from a space being cooled, and that heat is Q2 and providing this heat with the help of some work input actually. So the refrigerator machine should need some work input, and that work, using that work, that heat is taken from this space to be cooled and provided this heat and amount to the surroundings, and which is actually T is equal to T atmosphere pressure. And now we can see that in the next slide we can see that for the context of the refrigerator and the heat pump, the performance is expressed in terms of the coefficient of the performance, that is COP, which represent the ratio of the desired work effect to the work input actually. So COP is equal to the desired output divided by the work input. So in the cases of the refrigerator, the desired effect is to the amount of heat Q2 which is extracted from the space to be being cooled, and this space at the lower temperature. So COP of refrigerant which is equal to heat extracted from the lower temperature divided by the work input. So that is the Q2 divided by W actually. So from the principle of this energy conservation, we can know that W is equal to Q1 minus Q2, and the COP of refrigerant which is equal to Q2 divided by Q1 minus Q2. So depending upon this type of refrigerating system, the value of the COP should be less than 1 or maybe the greater than 1, because in the most of these refrigerating machines, the value of the COP lies between the 3 and 4. So the COP are greatest when the temperature difference are the least. So in the cases of the heat pump, okay, yeah, in the cases of heat pump, the heat is the desired effect is the amount of heat Q1 supplied to the space being heated. So the heat rejected at a higher temperature divided by the work input will be the COP of the heat pump. So that is equal to Q1 divided by Q1 minus Q2. So that is equal to 1 plus Q2 divided by Q1 minus Q2, which is equal to 1 plus COP of the refrigerant. So finally, in this one, the COP of the machine which is operating at the heat pump is higher than the COP of the same machine when operating at the refrigerator by the unity. So the COP of the heat pump is sometimes termed as the energy performance ratio. So I think this is enough for today's class, and for tomorrow we will doing some for the next class we will doing some rating or this capacity of the refrigerating unit and some problems. Okay, anyway, thank you.